Let's talk about k-means clustering in this video. So let's first quickly understand what is clustering. Clustering is basically an unsupervised learning, and when you have a clustering model and if you provide bunch of inputs to that model, you can expect outputs as set of clusters. Basically what it will do is it will assign those inputs to set of clusters, and each data will be assigned to exactly one cluster. So a cluster is nothing but group of similar items. How does it work? How do we do clustering? Because in unsupervised learning, we know that we won't have any label data set. So we somehow need to find similarities between the data and group them into similar clusters, right? So how do we do that when we have data set and we don't have any other information? Well, the first thing that we need to find out is how many clusters we want. Okay, so this is the first thing that we need to work out, how many clusters we want. Then we need to work out, okay, now I know I need 5 clusters, and what would be the center for each of those clusters? That is what I need to work out next. Then I will be finding out how close each of the features or each of the data that I have are to the cluster centers that I have. Okay, so we first find out how many clusters we have, then we will work out the center for each of those clusters, and then we will find out how close or far away each data point that I have are from the cluster centers. Okay, now if you think of a data like this, we have a data set with the 2 features, and if we plot them in a xy coordinates like this, imagine that this is how it looks like. And just by looking at this, you'll be able to say that, okay, I need 2 clusters. And you can also kind of say that this is going to be the center point for these clusters, because just by eyeballing the data, we'll be able to figure out the center point for each of the clusters, right? So then you'll easily be able to create the cluster. But this will not be always possible when you don't know the data, and if the data shape doesn't look like this, right? So this is like a chicken egg problem. Now you don't know how many clusters you need, or how many clusters you may need, and you don't know what is the center for each of those clusters. Only if you know those 2 things, you'll be able to work out how far each data point is from the cluster's center that we have identified. But now we don't have any of them. How do we solve this? Well, in general, whenever we come to face this kind of problem, whenever we face this kind of chicken and egg problem in algorithms, we go with random value. We randomly pick one of them, and then we will make this randomly selected value better and better. Okay, when we talk about algorithm later on, you'll basically understand what I mean by this random pick. But basically, in general, in any computer algorithms, this is what we do. If we ever face this kind of chicken and egg problem, then we pick one of them randomly, and then we try to make the randomly selected value a better value iteratively. Okay, now that is out of the way, let's quickly understand what is k-means. Okay, so we're talking about k-means clustering. We understood what clustering is, but we're talking about k-means clustering, right? Let's quickly understand what k-means clustering is. K is basically the number of clusters we are going to have. Previously, we have seen that we are going to randomly select the number of clusters, and if we choose 3 clusters, then k is going to be 3. If we choose 5 clusters, then k is going to be 5. Then what this means refers to arithmetic mean. Okay, that is what we're talking about, because we are going to use arithmetic mean to find the center or centroid for each of the clusters. That is why this algorithm is called k-means. We are going to have k clusters, and we are going to identify centroid for each of the clusters using the arithmetic mean. Now let's look at how this algorithm works, how this k-means algorithm works. First step is we need to choose k. Okay, once k is chosen, we need to randomly select centroids. If we have selected k as 3, then we need to choose 3 centroids randomly. Again, we don't know where they are going to be, and they may not be right. 99% of the time they'll just be random. But that is what we want to do first, because this is basically the chicken and egg problem, and we randomly pick centroid and we try to make this centroid better and better iteratively. Okay, so if you take this example, if we have data like this, then we have randomly selected k as 2 and we have randomly placed 2 centroids. Okay, so as you can see from this image, it is not correct, but that is what we want. We just randomly select the centroids for 2 clusters, and this is how it looks now. Then what we will do is we'll assign data to the closest centroid. Here if you see, each of these circles are data points, right? So now if you look at this, this might be closer to this centroid, whereas this might be closer to this centroid. So this way we'll assign data to the closest centroid. Once we have done that, we will recalculate the centroids. So if we have allocated bunch of records to this centroid and a bunch of records to this centroid, then we will recalculate the centroids based on the arithmetic average of the newly allocated data points to each of the centroids. Then what we will do is we'll repeat this. We'll repeat step 3 and 4 until we reach convergence. What is convergence? We will reach a point where the centroid is not changing anymore. Okay, that is what we call as convergence. Once we have reached that point, we will stop. When we stop, we might have clusters, something similar to this. Okay, from this point onwards, even if you assign the data to the centroid which is closest to it, the cluster won't change. That is the point you stop. Okay, that is the point we have achieved convergence, and that's when we stop. Now, how do you choose k? We have seen that we randomly choose some value for k because you don't know how many clusters are going to be there. You can't just eyeball it, right? So you can't always eyeball. You need to find a way to choose k, right? And for this, data scientists use a method called elbow method. What is elbow method? In elbow method, we run the algorithm that we have seen in the previous slide multiple times. With the different value for k. Okay, and then once we have results from those models or those trained models, we plot the total error. So each models will have something called error. Error basically indicates how far data is from its centroid. Okay, so if we have assigned a data point to a wrong centroid or wrong cluster, we can expect the error to be really high. But if we have assigned it to a correct cluster, then we can expect error to be really low. So if we have selected excessive number of clusters or less number of clusters than that we need, then we can expect the error to be really high. The error will be really low on an optimal number of clusters. Okay, so we can see that in this graph here, this is called elbow graph. Here, the squared sum of error is on this axis and number of k is on this axis. If number of k is really less, then we can expect that the error is really high. If the number of cluster is really high, then we can see that the error rate is really low, but it is not changing the error rate any further, right? So it kind of saturated. So which means as we increase the k, it is not reducing the error, which means increasing k is not going to be effective. So we need to find a point where the error rate has come down, but at the same time, increasing k is not going to reduce the error even more. So that point is called elbow point, which is this. And this is where we have optimal number of k. So if k is 3 here, then that is what we need to use. That is going to be the k. So we use a model which we used with the k equal to 3 as our final model, and that will be our final resulting model. Now there are a few gotchas that we need to know. First one is the first centroid placement. We know that this is actually random placement, right? Although this is random placement, if we picked really bad random centroid, then the overall grouping will be really poor. Okay, because because of the math behind it. If we randomly selected really poor centroid, then the final grouping will be really bad. This is because we have this concept called local minimum, and because of that, picking a wrong random value is going to cause problem. How do we solve this? There is no best way to solve this. We just need to run the same algorithm multiple times by randomly selecting different starting centroid. Okay, that is the only way that we have now. So if the first time if we have picked really bad random values, hopefully the second time we may not do the same. So the algorithm will do a better job. And we need to go with the run which has resulted in less error, or the lowest error. So then the second issue is that because clustering works based on the distance between centroid and the data points, it works very well for shapes like spheres. If you plot a data and if that looks like sphere, then it works fine, but it doesn't work well when the shape is other than spheres. Like, if you have some sort of weird shape, then clustering is not the best. Okay, it won't do a great job. So that is something that we need to keep in mind. Okay, so that is all basically I wanted to cover in this video. I hope this is useful. Thank you.